So, searching algorithms. All we need to do is understand linear search, binary search, and then the difference between the two. And we do need to know the mechanics of the algorithm. That is, how does the algorithm run? The fact that we should know this probably means that we may be asked by the examiner to write a flowchart to represent linear search or to write binary search in pseudocode or something like that. So you should know how these work. They're both fairly straightforward though. Linear search takes a set of data and it literally does what you would do if you had no knowledge about the data, and it just checks them one by one. So let's say your task is to find the person whose mark equals 73. If that's your task, the linear search will literally search through each element one by one. So it starts and goes, right, so Steve, his mark is 43, it's not Steve. Emily, her mark is 47, not Emily. Not Harry, not Alex, not Max. Aha, Sophie's mark is 73. We've found the correct answer. Sophie is the answer. That's linear search. You just go 1, 2, 3, 4 until you find it. Now, something characteristic of this is one thing that's good about it is the data does not need to be sorted. It is sorted in this example, but it doesn't matter what the nature of the data is. It's just going to try every single element. Another good thing is that it can find things almost instantly, because if it happened to be that we were looking for the student whose mark was 57, it would just almost immediately find it. But of course, the downside is that it might be that we want the student whose mark is 87, and then we have to go through the entire data set before we find it. Obviously, this is a very simple example, but if we had an array with, say, 10,000 records, going through every single element until we got to the final record would be very, very silly and very costly indeed. And so, especially as the data size gets bigger, linear search is not very efficient. The second example is something called binary search, which is a little bit more complicated, but essentially people call it divide and conquer. The example, essentially what we're looking at is a higher or lower approach. So what we do is we look at the data and we take the middle point, which is about here, and we say, right, the middle point of the data, the answer is 62. Is that more or less than 73? That's less than 73. Therefore, we can intuitively guess that because this is a sorted list, as this element is less than 73, and all the elements to the left of it are less than it, because of course anything left of Alex who got 62 marks will have 62 marks or fewer because it's a sorted list. The fact that Alex and everything to the left of Alex, is less than our target means that everything to the left can be forgotten, so we can just get rid of it. Then we look at our new data set and we pick a new midpoint, let's say Alice. Now we say Alice's mark, is that higher or lower than the target? Well, the target is 73, Alice's mark is higher, therefore Alice can't be the right answer, and nor can anything to the right of her, because anything to the right of Alice will, again, in a sorted list, be greater than her. So if Alice is too big for the number, so is John. Then we take our new data. I mean, taking a midpoint seems a bit silly, but let's say we choose Max. Max is not the right answer, and so now we're left with Sophie. Hopefully that makes some sense. I'll go through again with a different example to show what might happen. Let's choose 57. This time we pick the midpoint. We say, is 62 greater or less than 57? 62 is greater than 57, therefore anything after the ordered list must also be greater than 57. So all of this data can be ignored. Now we have a new data set, we pick the midpoint, which in this case happens to be Emily. Aha, we've found it, that's the answer. Advantages of the binary search is that it's much more efficient for big data sets. If any of you have a mathematical approach to this, the way you can think about it is you are literally halving the data set each time, because you're going find the midpoint and then delete half the data set, and at that point delete half the data set, and at that point delete half the data set, and that forms what you call a logarithmic curve, a curve that sort of plateaus out at the top. Essentially, if we double the data set in a linear search, there are twice as many data points to check because we're checking every single one of them. But in a binary search, because we half the data each time, doubling the data set in size only adds one more step of execution. Because if we had, twice as many values, let's say, as many values on again, the first step we do would be to check something and then just delete half the data set. So even twice the size of the data set is only one more step, whereas for linear execution, double the data set, that's double the number of checks. The disadvantage, primarily the disadvantage, is that the data has to be ordered. If the data is not in some kind of order that you can check by, then you can't make this assumption. If this was in random order, I couldn't say that just because Max is wrong, everything to the right is also wrong. It must be ordered, and that's a problem. And often the problem that we have is if we have an array, is it more efficient to linear search it, or is it more efficient to sort it and then binary search it? And the answer to that really depends on the problem. So yeah, that's your main pros and cons. I haven't found an official list anywhere of the disadvantages and advantages you should know. All I suggest is that you go through and have a look at the mark schemes when you're doing practice papers and see what they say. But the main ones would be binary search is much more efficient for bigger data sets. Linear search, that their main advantage is that linear search doesn't need the data to be pre-ordered. In general, most programming languages actually use linear search for a data set below a certain size. Say it's 100 data points, they use linear search. Anything bigger, they use binary search. Works out easier. So that's your searching algorithms.